We're going to run some dependent t-tests in SPSS, but first of all I'm going to give you a little background information, and I'm going to tell you about the two types of dependent t-tests, the null hypotheses and alternate hypotheses, the research questions, and one and two tail tests. So first of all, there are two types of dependent t-tests. In the first type, we have pre-test and post-test scores measured for a number of individuals, and we want to compare the mean of the pre-test to the mean of the post-test. In the second kind, we have pairs of individuals, for example, twin pairs, and we're measuring them on the same variable, for example, weight, but one of the groups of twins may have some sort of treatment, like a medical treatment, for example. So when we're running a dependent t-test, the null hypothesis is that one mean is equal to the other. So for the one-tailed test, the alternate hypothesis is that one of the means will be higher than the other. For example, we may ask, is achievement higher at the post-test than at the pre-test? In the two-tailed test, where the alternate is that the two means are not equal to each other. So we're simply asking if there's a difference between those two means. So I've got two examples set up for you. In one of them, the dependent variable is family harmony, and this is measured at Thanksgiving, which is the pre-test, and again at the winter holidays, which is the post-test. So our research question is there a difference in family harmony between Thanksgiving, which is the pre-test, and again at the winter holiday, which is the post-test? And this is a two-tailed test. In the next example, the dependent variable is depression. And again, this is measured at Thanksgiving and again at the winter holiday. So our research question for this example is there an increase in depression between Thanksgiving and the winter holidays? And so this is a one-tailed test because we're asking whether there's an increase in depression. And we're going to use the alpha of 0.05, which is the convention, especially in the social sciences. Okay, so let's go to our data file, which is right here. And notice we have a column of data for depression, Depress 1 and Depress 2. We also have Family Harmony 1 and Family Harmony 2. So we've got these pairs matched. So to run this dependent t-test, we're going to go to Analyze, click on that, drag down to Compare Means, and over and down to Paired Samples t-test. And when we release that, we get a box that looks like this. Here are all our variables listed the way they're listed in our data set. And here we have, we're prompted to put two pairs of variables together. So first of all, our first question was about Family Harmony 1. So I'm going to take Family Harmony 1, the pretest. Notice the arrow is pointing toward the direction of the box with the paired variables. So I'm going to click on that, and it moves the variable over. Now if you click on this and you move the wrong variable, don't worry, you can just highlight it again. Notice the arrow is pointing in the other direction. You can move it back. But I actually want Family Harmony here. Then I'm going to click on Family Harmony 2, click on the arrow, it moves it. Now I'm going to, moved it back, moves it again. Now I'm going to move to my next variable, which is depression. So I'll highlight Depression 1, click on my arrow, highlight Depression 2, click on the arrow. Okay, and then I'm going to click on OK. Okay, so here are my two pairs. I have my mean, my sample size, and my standard deviation for the pair of Family Harmony at Thanksgiving, which is the pre-test 1, and at the winter holidays, the post-test 2, and the same thing for depression. And down here I have my t-test, which we're going to talk about in just a minute. So what I have done is let's go down past these instructions. I have copied this information into the Word document, and I have highlighted in red the information that you need to report. So this includes the mean and standard deviation of sample sizes for the pre and post tests on both variables, And here's the T, degrees of freedom, and two-tailed significance for family harmony and depression. So let's start out here. First of all, we're going to create a table of mean, standard deviation, and sample sizes for the pre-test and post-test for family harmony and for depression. So here are my variables, family harmony and depression. Here's my pre-test time 1, my post-test time 2, mean, standard deviation, and sample size. I've got that twice. And I'm simply going to copy my information. For family harmony, the mean at Thanksgiving is 7.71, and in the winter it is 7.91, not very different. So I'm going to put my mean at the pre-test 7.71 here, my mean at the post-test 7.91 here, and I think the rest of it is pretty straightforward. So the next thing I'm going to do is to look at my output here for family harmony. So let's go down to the output. And you notice there are 2 rows here under the paired samples test. So my pair 1 is for family harmony 1 and family harmony 2. And my T here is minus 1.367. My degrees of freedom are 122. And my probability is 0.174. So let's go back up here. Remember that we said we were going to be comparing our probability to the 0.05 alpha level, and 0.174 is greater than 0.05, so we're going to retain our null. We're going to say there's no significant difference, and so we're simply going to say there is no significant difference. T with 122 degrees of freedom is equal to a minus 1.367. The probability is equal to 0.174. In mean family harmony from Thanksgiving, where the mean was 7.71, to the winter holidays, where the mean was 7.91. So notice this is only 0.2 of a different point difference. It's not very different. So our result, it makes sense to say there's no significant difference because these means on family harmony are very, very similar. So let's go and look at our next result, which is for depression. And let's go down here to depression. Now there's a couple things we want to pay attention to. First of all, remember this is a test for differences between means, and in this particular, with this particular variable depression, the question was there an increase in depression? So at Thanksgiving, the mean was 2.66, and in the winter holidays, the mean was 3.15. So there's definitely an increase. Sort of counterintuitively, depression increases over the holidays. Now, we have to remember that the way SPSS calculates this is it puts whatever variable you put in first, in our case the pretest, we take that variable and then subtract the post-test. So since our pretest is less than the post-test, the resulting T that we get is a minus, and it's minus 2.781. Now if we had gone and put, since we're looking for an increase, we could have put depression 2 in first and depression 1 in second. If we had done that, all our results would be the same, with the exception that we would not have a negative sign. So we really need to keep track of whether this is positive or negative and which variable we entered into our analysis first. Now in the case of family harmony, it really didn't matter because we were doing a two-tailed test. We just wanted to know if it was different. And then we're going to refer back to the means. Okay, but here our result is that there's an increase in depression even though our T is a negative 2.781, degrees of freedom 120, and our two-tailed significance is 0.006. Now we have a two-tailed significance, which is what SPSS reports. However, we're asking a one-tailed question. So what we need to do is to take this value 0.006 and divide it in half in order to get the one-tailed significance, which is what we're looking for. And I've explained it here. We're going to take 0.006 and divide by 2. We get 0.003, which we're going to compare to our alpha of 0.05. This is less than 0.05. So we're going to say there is a significant increase. We're going to reject the null that the means are equal. So here we're going to say there is a significant increase. T with 120 degrees of freedom is a minus 2.781. Our probability is 0.003. For mean depression from Thanksgiving, where the mean is 2.66, to the winter holidays, where the mean is 3.15. So notice in this write-up we talk about a significant increase, so we're explaining what happened, whereas in our previous example we just talked about a difference.